Welcome to Learning Math with Mr. Tan. Today I'll be talking about how to solve simultaneous equations using the elimination method. To begin, let us look at a recap of what we did in secondary 1. In secondary 1, we dealt with equations with one variable. So what we have are like equations, for example, x plus 3 equals to 5. So what we do is to just subtract 3 on both sides because I need to remove the positive 3. And then what I'm left with is x equals to 5 minus 3, which gives us x equals to 2. Now in secondary 2, we have equations with two variables. And what happens here is if I were to do the same thing, then I'll have x equals to 5 minus 3y. And I'm not solving anything because I still do not know what is the value of y. So I'm still stuck. And in general, I would say that, alright, if we were to notice in secondary 1, our equations have one variable and therefore we are able to solve it. So an equation with one variable, I'm able to solve it with one equation. In secondary 2, we deal with equations with two variables, and therefore we need a second equation in order to find what is the value of y or x before we find the value of the other variable. So in general, this is what it means about simultaneous equations. I'm actually solving two equations or sometimes more simultaneously so that I can find the variables in the equations. Alright, so in general, if there are two variables, we need at least two equations. Three variables, at least three equations, and so on. So for here, we will focus on just two variables, and let us see what we do with the elimination method. So elimination method simply means I need to eliminate or remove, in simpler words, remove one of the variables. So if I were to just focus your attention over here with the x, what I can do is to take x minus x, then I will have no more x to deal with. Then I only need to deal with the y, which I can easily solve for that value. So that's the general idea. Now, first of all, I need to name the equation so that I can explain in my working what I'm actually doing. So I've named the equations as equation 1 and 2, and that's really quite a conventional way of doing things. Now, the second thing I need to do is to identify which variable I'm to eliminate. Now, here, it seems quite straightforward that we will eliminate x, but in general, I can actually remove either variable x or y, except that you notice that for y, the coefficient, which is the number on the left of y, they are different. So for equation 1, the coefficient of y is 3, equation 2, the coefficient of y is 2, and therefore if I were to subtract them, it's still going to give me y, and I can't actually eliminate it. So therefore, but for an introduction, we'll just focus on x. Later on, I'm going to show to you how to eliminate y. Okay, so let's begin. So if I were to take 1x minus 1x, then I will eliminate x because this is 0x, and 0 times x is just going to give you 0. So there's no more x, and that solves part of our problem. So I'm going to take equation 1 minus equation 2, and what I will have is 1x. I know in general we just write x, but I just want to bring in the numerical coefficient for you to see so that it's easier to understand. Alright, so this is really equation 1 minus equation 2. And then going further from there, I have plus 3y minus 2y, which is again equation 1 minus equation 2. And then on the right hand side, I have 5 minus 3, which is also equation 1 minus equation 2. So this whole entire long step shows to you how I make use of equation 1 minus equation 2 step by step, starting from variable x, then to y, and then to right hand side the constants. So I can actually simplify my working a little bit. Alright, because I already set out with a goal in mind to remove the variable x. So therefore I know that x minus x is just eliminate x. So I'm not going to put the x in. Instead, I just simply put 3y minus 2y equals to 5 minus 3. and it's quite understandable. So this means that I have y equals to 2, and therefore I'm going to name this as equation 3, and I'm going to substitute this new finding into either equation 1 or 2. Now it's not actually necessary to put equation 3, it's just I don't want to write the entire equation, it's up to you. You can say substitute y equals to 2 into equation 1 or into equation 2. I'm going to choose to sub this back into equation 2 because the numbers are just smaller, so it's easier to deal with. So x plus 2 times of y, which is 2, times of 2 over here. Alright, just let me annotate that, and equals to 3. So if I were to solve for x, what I'll have is x equals to 3 minus 4, which is just negative 1. So therefore, hence, my answer would be x equals to negative 1 and y equals to 2. Now here, I should not proceed without checking the answer. Now, what this does is also to show to you the concept of simultaneous equation. Now, this pair of solution comes together as a pair, and simultaneously I'm going to substitute this back into equation 1 just to check my answer. Of course, I would expect if I were to substitute that back into equation 2, where the value of x came from anyway, it should give us consistent equations on left hand side and right hand side. So I'm not going to do that. I'm just going to check for equation 1 only, and you can try for equation 2 on your own. So what happens is x equals to negative 1. So on the left hand side, I have negative 1 plus 3 times of y, which is 2. Alright, and this gives us 5, which is the same as the right hand side of the equation, and therefore we conclude that our set of solution actually fulfills equation 1, making the left hand side and right hand side consistently equal. Alright, so that is for example 1a. Now in example 1b, I'm going to stay with the same pair of simultaneous equations, but remember I said you can actually remove variable y, and I'm going to show to you how. So although it's straightforward to remove x, but let us see what we can do to remove y. So again, I'm going to name this as equation 1, this as equation 2, and now it's not so straightforward because I can't just take 3y minus 2y, there's still a y. I can't take 3y plus 2y, for example, and that's still going to give me 5y. So I can't just eliminate y just like that. So I need to do something to it. So let's focus on this, and it is a concept that we used in, for example, evaluating fractions. For example, if I were to have 1 over 3 plus 1 over 2, then I would need to make a common denominator using the concept of LCM. Because this concept of LCM makes both numbers the same, alright, it is very powerful for us to make the coefficients the same. So let me just put this down. LCM of 2 and 3 equals to 6. Therefore, what I'm actually doing here is to raise 3y to 6y. And the other one, I raise 2y to 6y. And if I were to do this, then both equations will have 6y. And 6y minus 6y means I can eliminate y. So that's the whole objective. So to raise 3y to 6y, I need to multiply by 2, which means my first equation, I need to multiply throughout by 2. Now, I can't just raise 3y to 6y without doing anything to the x and the constant. That would mean the equation gets, it loses its balance. So I need to do that throughout. Right, so next thing is, if I were to raise 2y to 6y, then I'll need to multiply 3 throughout, and therefore equation 2, I need to multiply 3 throughout. Okay, so let me remove the annotation that I don't need anymore. Okay, of course, actually I also don't need that. And then, so if I were to multiply 2 throughout equation 1, what I'll have for here is 2x plus 6y equals to 10. Then for equation 2, I multiply 3 throughout, I'll have 3x plus 6y equals to 9. And I'm going to name these two equations as equation 3 and 4. So equation 1 become equation 3, equation 2 becomes equation 4. Now, I have 6y and 6y. That means if I were to take equation 3 minus equation 4, I can remove y. Or if I were to take equation 4 minus equation 3, I can remove y. So which way would I choose? So it boils down to a question of, do you want to take 10 minus 9? Or do you want to take 3x minus 2x? Either way, you're going to get the same answer. So that doesn't matter. But for me, I prefer to take 3x minus 2x. Therefore, I'll take equation 4 minus equation 3, and what I will have over here is 3x minus 2x. So of course 6y minus 6y will be gone, and be very careful here because I'm taking equation 4 minus equation 3. Therefore, I will have to take equation 4 minus equation 3, which means I actually have 9 minus 10 on the right hand side. Okay, so x equals to -1 as we have seen earlier on, and then therefore I can substitute this. You can call it equation 5, doesn't matter, right, into either one of the equations. So this time around I'm going to do the substituting back into equation 1, and what I'm going to have is -1 plus 3y equals to 5, and then 3y equals to 6, y equals to, oops, let me just write the 6 properly, y equals to 2 as we expected. Alright, so what I'm trying to show here is earlier on we eliminated x, now we eliminate y for the same pair of simultaneous equations and we get the same answer. So when the coefficients are the same, we can just remove it directly. When the coefficients are different, then we need to find the LCM of the coefficients. Now what's going to happen if I have equations like this in example 2? Okay, so of course I can actually, again, same thing, find the LCM of 5 and 3 and then solve that. Give it a try after I finish example 2 to see whether you get the same answer. So one question on simultaneous equations, you can actually do it in 2 different ways for the sake of practice. But what I'm going to focus instead is actually this part. Now, numerically, the coefficients are equal, but the signs are different. So if I were to do the same as just now, taking one of the equation minus away the other equation, what I will have, for example, is this. For example, I take 2y minus away the negative 2y in the other equation. What I will have is 4y. Alright, so again, my y doesn't get eliminated. So the problem here is the signs are different compared to previously. The x are both positive, or if they are both negative, it's going to be the same thing. So here, one is a positive, one is a negative. So we need to do things a little bit differently. So the concept here is I'm going to take the first equation, or one of the equation, plus the other equation, and to do that I form a 0 pair, so I have 0y. Alright, and therefore that means it's 0 and y would be eliminated. So let's begin. So what I need to do first of all again is to name this as equation 1, this is equation 2, and bear in mind just now I have mentioned that I'm going to take 2y plus negative 2y. So let me show to you one more time. It is 2y plus negative 2y. So this is the 0 pair that I'm talking about, and it's going to give me 0y, which is just 0. So I'm actually adding the two equations instead. So let's see. Does it seem to matter which which way we add the two equations, I can actually take equation 1 plus equation 2, and what's that going to give me is just negative 2y plus 2y, and it's still going to give me 0y, so it doesn't matter. But I'll just do it this way. So 3x plus 5x on the left hand side, and then of course I have 2y plus negative 2y, which means a 0 pair, so y is eliminated. And then I have 12 plus 4. So again, I'm actually taking equation 2 plus equation 1, equation 2 plus equation 1. So that's all good. And what I'm going to be left with is 8x equals to 16, x equals to 2, and then the rest are just very standard steps which we have seen over and over. So substitute equation 3 back into either one of the equation. I'm going to sub into equation 1, and then 5 times of x, which is 2, minus 2y equals to 4. Well, you can choose to substitute back into equation 2, and that might make things simpler. So I have negative 2y, equals to 4 minus 10, which means negative 2y equals to negative 6, and then y equals to negative 6 divided by negative 2, which means it is actually just 3. Alright, so therefore x equals to 2, y equals to 3. So these examples actually gives you a very quick introduction on elimination method, although I know this has been quite a long video, but that's because this is your first exposure to simultaneous equations, and there are quite a few concepts to go over, and I don't really want to break it into a few videos, into smaller videos, and then you have to go into different videos to watch the same concept. But with this concept of elimination method comes a few other concepts as well, or sub-concepts. So I hope this video helps you to understand in various situations how you perform the elimination method, and do look out for my subsequent video on substitution method. Until next time, thank you for watching and goodbye.